In this video, I'll explain the concept of rank correlation coefficient. So, in the previous video, I have already explained the correlation coefficient, which tells you the association between two quantitative characteristics. So, when the characteristics are qualitative in nature, that means you can't measure them numerically. In such cases, to find out the association between those two qualitative characteristics, we use the rank correlation coefficient. See, for example, height of any person, so then it can be measured and we can have the numerical value for it. So it is quantitative characteristic. Suppose if you have to judge a singing competition, and in that case performance by an individual cannot be measured numerically. Instead of that, you can assign rank for the best performance as first rank, then second rank, third rank, and so on, because that was the qualitative characteristic. So, if you want to find out association between two qualitative characteristics, we use rank correlation coefficient. You can say it as in between two ordinal variables also, because order can be defined among the ordinal variables. So if the characteristics are ordinal variables, though in that case you can use the rank correlation coefficient. Now, to measure the association between two qualitative characteristics, we use Spearman's rank correlation coefficient. It is denoted as RS and given by the formula 1 minus 6 sigma di square divided by n into n square minus 1. Suppose you have two variables x and y, these are qualitative in nature. So, if you want to find the association between these two variables, then we use this formula. Now this first variable x has n observations and the second variable y has n observations, and rx means the rank of the first variable, ry means the rank of the second variable. Then the formula is 1 minus 6 sigma di square. Di means rx minus ry, the difference between the two ranks, divided by n into n square minus 1. Let us take one example. Here is the problem. Suppose we have ranks of 8 students of BSc Statistics and Mathematics. On the basis of rank, we would like to know that to what extent the knowledge of the student in stats and maths is related. We want to find out. So here they have given the ranks directly, rank in statistics and rank in mathematics. So there are 8 students. You would like to know now what is the association between the knowledge of student in stats and maths. That means if a person is having good rank in stat, then what about his knowledge in maths? See here, I have drawn the table here. Rank in stat as Rx, rank in maths as Ry. Then I have to find out the difference in rank, Di equal to Rx minus Ry. Then I want Di square, because as per the formula here, n equal to number of observations is equal to 8, because there are 8 students. So find out the difference, Rx minus Ry. This is minus 1, 2 minus 4 minus 2, 3 minus 1, 2, then 4 minus 5 minus 1, 5 minus 3, 2, 6 minus 8 minus 2, then 7 minus 7, 0, 8 minus 6, it is 2. Next I want di square, so square all these values, 1, 4, 4, 1, 4, 4, 0, 4. So now I need the sum of all this. So summation of di square equal to, here all values, 3, 4, 5, 5 4 is 20 plus 2, 22. Substitute it in this formula. So this is equal to 1 minus 6 into 22 divided by n into n square minus 1. 8 into 8 square is 64 minus 1, 63. Now I have to simplify all this. This is equal to, so you'll get 1 minus 132 divided by 504. So when you simplify this, I'll write here RS is equal to, you can check, the final answer would be 372 divided by 504, which is equal to 0.74. So we got the association between those two variables, that is rank in stat and rank in maths, as a 0.74. It is the positive value, and there is a positive correlation between those two variables, we can conclude, and it is nearer to 0.75. If you have the values of correlation coefficient from 0.75 to 1, then there is a strong positive correlation between the two variables. Therefore these two variables are positively correlated. That means the person or the student who has good knowledge in stat has good knowledge in mathematics also. They are correlated in a positive way. Now see the second problem. Calculate the rank correlation coefficient from the following data. Here the values of x and y, two variables, given directly. Ranks are not given. Just the data values are given. So first you have to allot the ranks for each value, then you have to find out the difference between the ranks. So I'll write the table x y. X values are 78, 89, 97, 69, 59, 79, 68. Then I have to assign the rank for these x values, then y values, rank for y values, then di rx minus ry, then di square. So these are the columns of the table. So rx means the highest value will be ranked as 1. So out of all these, the highest value is 97. So this is the having the rank value 1. Then 89 2, then 79 3, this is 3, then 78 to 4, then 69 5, 68 to 6, this value is 7. Next is this data: 125, 137, 156, 112, 107, 136, 124. So the here highest value is 156, it is having the rank 1. Then the next highest is 137 2, then 136 3, then 125 4, 124 it is 5, then this value is the 6, and this value is 7. Now you have to find out the difference between these two ranks. 4 minus 4 is 0, 2 minus 2 0, 1 minus 1 0, 5 minus 6 minus 1, 7 minus 7 0, 3 minus 3 0, 6 minus 5 1. Then di square 0 0 0 minus 1 whole square 1 0 0, it is 1. So the sum of di square, summation of di square equal to 2, because 1 plus 1 2. Then number of observations is equal to 7. Therefore rs is equal to the Spearman's rank correlation formula, sigma di square by n into n square minus 1, which is equal to 1 minus 6 into 2 divided by 7 into 7 square is 49 minus 1. So 7 into 48, 6 to the 12, then 12 fourths are here. So you'll get 1 minus 1 by 28. So it is equal to 27 by 28. I'll write here. RS is approximately equal to 0.96. So this is the value of the Spearman's rank correlation coefficient between these two variables x and y. And you can say that there is a positive correlation between the two variables, and there is a strong, which is very close to the value 1. So it is a perfect correlation. Value 1 means perfect correlation. So it is very close to 1. Hence it is a strong positive correlation between the two variables x and y. I hope you understood the concept of finding rank correlation coefficient. Thank you for watching.